Now let's talk about regression coefficients. Actually, the meaning of regression coefficients in MLR is absolutely the same as the meaning of regression coefficients in simple linear regression, right? So the regression coefficient gives you an idea how y grows if you change x, okay? In this case, we just have several x values, and then we have a little bit more information from the regression coefficient. So let's discuss that. Okay. So in regression coefficients show influence of each x variable to the response value. It means you can compare this influence. You can see which variable is more important, which variable is less important, right? Let me make a new model. In this case, I will use three variables, age, region, as before, and I add sex as well. So assuming that probably this gender will also change the salary. Probably it's quite common, at least in the 80s. Maybe now it's not the case, but in 80s, women earned a little bit less than men. So let's see if it indeed the case in our sample. Okay. So these are regression coefficients, and remember these are the real values. So I just took an output from R. So you can see that indeed sex has a small negative influence, right? So it means that if sex is you change sex from -1 to +1, then you will have some small decrease of the salary. Let's discuss this. Okay. Well, this is the model. It says we take age and multiply to 805. So it means that every time a person gets 1 year older, in average, this person gets a bit larger salary by 805 a year. Then region, and in this case, the region, the coefficient for region is 3,616. And it means that the difference between the Scandinavians and Mediterraneans will be twice of this. Why twice? Because this tells us what happens if we change region by 1. But to get from Scandinavia to the Mediterranean, you remember we have -1 and +1. We actually changed the region by 2. So it means that the average difference between the salaries in our sample, between Scandinavians and Mediterraneans, it's actually twice of this. So it's about 7,000. Okay. Then the same for sex. So in this case, we have -175, and you remember we also have sex -1 and +1. So we can assume that the difference between the average difference between males and females in our sample, at least, will be 350 euro a year. But will it be the same for the population? Let's look at the statistics, right? So this is you remember, this is the results of the t-test for the coefficients. In this t-test, we assume that the proper coefficient, for example, in this case it's B0, is actually 0. B1, beta 1 is 0, beta 2 is 0, and then beta 3 is 0. So this is our null hypothesis in the t-test. Now look this one. So indeed, it seems like our sample is absolutely not extreme for this null hypothesis. So we do not see any evidence that the intercept for the population will be not equal to 0. So it means that the intercept of population probably equal to 0, right? Now look at the age. That's the chance to get a sample like we have, or even worse, if indeed this is true. So that's the chance to get our sample, or even more extreme sample, if in population age does not influence the salary. So it means that you see that it's 0 actually. So we definitely know that age has an influence to the salary. Okay. The same about region. That's the chance to get a sample as extreme as ours if in population region doesn't influence the salary, and it's very small value. But for the sex, it's a funny one. So if indeed in the population sex doesn't influence the salary, that's the chance to get a sample like this, or like ours, or even more extreme. So in fact, sex doesn't have any influence, at least for the population our sample came from. Okay. So now we can make conclusions. Well, first of all, gender doesn't have any influence on the income. We don't see at least this influence. We don't see an evidence for this influence. Becoming 1 year older adds, in average, 805 euro a year. And then in Scandinavian countries, people earn double of this, 2 of this. So it's about 7,232 euro a year more in average. Okay. But you remember these values are for our sample. What if we look at the population values? Well, the problem, we don't know the population values, but we of course can compute confidence intervals. For example, in this case, it's 95% confidence, right? So you can see that for the population, the intercept may be negative, may be positive. We don't know the exact value. So we assume it's 0. For the age, this will be between 720 and 890 a year. And then for the region, it looks like this. and for the sex it looks like this. So you can see for the sex the influence can be negative, can be positive. We don't know the real one, so that's why we assume it's 0. Okay. So now our conclusions can be changed to the following. So sex, gender has no influence on the income for the population. Becoming 1 year older adds between 720 and 890 euro a year in average. And in Scandinavian countries, people earn, I forgot to double this, so this should be doubled. Double of these two numbers in between euro more in average. So that's how we interpret the regression coefficient. So once again, you can think of regression coefficient as the impact factor of a particular variable to the y. Okay, and then if you, for example, make a let me use my original example about the houses, price of the houses. So you can think that, okay, if, for example, area has a certain coefficient, and then every square meter has this influence. Every square meter will add something to the price of the house. Okay. And then in this case, I just use this box, the error bar plot, to show you the regression coefficients for different variables. You can see that, for example, for the age, the regression coefficient is very narrow. So it's very clear impact of the age. For the region, it's a bit spread. So it means that we have a big variation of the values for the region salaries. And for the sex, you can see that it's spread also quite a lot. And also it crosses 0, right? So we don't see any evidence that sex has any influence.